I'm going to tell you something about the possibilities of an interactive 3D environment for communication. My name is Dillen Bruil, and I'm advisor for geodata at the company ROM3D. First, I'm going to tell you something about the interactive 3D visualizations, why 3D, and something about virtual reality we use in the company and augmented reality. And the second part is a live demonstration in Win3D. The program we have for the 3D visualization and for simulating resonance participation. I'm going to do that together with my colleague Arjan. First of all, I don't know if you know ROM3D, but we're a consultancy firm for sustainable agriculture and landscape. And we accompany governments, landscape organizations, and initiators from policy, and we did it from policy provision to permits. So quite a broad aspect that we do. And we design work sessions, we do consulting, we organize resonance meeting, and we have innovative tooling, and we visualize wind and solar energy. Like in the visualization you can see in the presentation, this is the normal landscape, and we can visualize it with solar panels, for example, and wind turbines. But yeah, why would you do it in 3D? You can do it in photos, but the photo you see here, we don't think it's really satisfying yet. It's not interactively adjustable. You can only view it from this location that we are right now. You need to take the photo, and there's no motion visible. So we have a 3D program based on GIS. So why GIS and 3D? Not everyone is able to read the maps. It's hard to imagine spatial impact, like you can see in the map here, with 4 wind turbines, 5 wind turbines, but you can't see what the spatial impact of it is. It's just a dot. Well, when you're standing on a road, you see this, which is quite different view. And you want variance in layout and the time. You want it to be accurate and reliable, and the world is 3D. So that's why we came up with a gaming engine, and that resulted into Win3D, which is a planning instrument to combine participative planning, GIS data, virtual reality, and gaming technology. It's easily providing insight to complex questions. We can show objects that do not yet exist, like, for example, wind turbines or solar systems, which we focus a lot on within the company. We can show the real sizes and the real distances, and with the gaming element, it ensures involvement. And we can apply this in all areas of the Netherlands, and it's based on a digital elevation model, building data, water bodies, vegetation, and aerial photo. And we can add a lot of 3D objects to it to make it more reliable and to show situations that do not yet exist. So what can you do with it? You can design or visualize wind and solar parks. We can do traffic simulations, nature restorations. I have an example from it in the Sallandse Heuvelrug, an area in the Netherlands. And we can use it to inform citizens, governments, initiators. You can name anyone who needs to be informed. So this is the first example of a solar park, which we made in the Win3D program. This is a top shot of the solar panels, and there is some landscape planning in it, with some trees, bird's eye view, some thicket to hide the solar panels. And this is a movie of the solar and wind energy business park in Ermelo, which is a city in the Netherlands. You can see the wind turbines generating energy. This is a new business park which needs to be realized, and there are some solar panels on the roofs of the buildings. And in this movie, we fly through the area and over the road to see how it looks like from the roads. I'll fast forward a little bit. This is one of the things we can do with our 3D program. Another short movie is there's research on shadow flicker. We're driving on the A16, a highway in the Netherlands, and on the right side there are some wind turbines with shadow flicker. And we use this movie to inform the governments on the shadow flicker to see whether it's disturbing and acceptable within the limits that there are. We can also use it for heat transition to make illustrations on, for example, energy classes for buildings. If they use a lot of energy, we can give them a different color than when they use less energy. And this kind of images make it more interesting to watch than just a flat map, a 2D map. We also have done some nature restoration with it. I'll go to a viewer for this. We have a viewer of the Sallandse Heuvelrug, and I can click a location. And we see a photo of the current situation. And the idea is to cut the forest and let the nature restore the nature as how it was in the past. So directly after cutting the forest, this should be the situation. And after 5 years, the trees should have grown. And after 10 years, even more. And this is also visible with 3D glasses, so you can see it in 3D. There's this this menu form. And I should get out. And the same we have done in the Carolina polder. It's also an area in the Netherlands. We use that for a wind park, to visualize a wind park. So we start, and this is a city. And there is a new wind park in the east of the west of the city. And with this viewer, you can see the new situation with the wind turbines. I can click several locations and see the impact of the wind turbines. And also this one can be viewed in a 3D viewer. This is all virtual reality. We can also apply augmented reality. We have an application for it. It's called TrueView Visuals. And we can see a new situation through the iPad's camera. So here you see me standing in the field taking a picture of the landscape, and we can visualize wind turbines in it. There's another location on the Veluwe. And here, this is a field without the wind turbines. And in this little movie, you see the wind turbines turning, and this is made in augmented reality. So we have an example of a wind park, Welsmeer. It's close to the German border near Weeze Airport. It's in the Netherlands actually, this wind park. But because Wind3D is only applicable in the Netherlands, I use the augmented reality option to visualize the wind turbines from Germany. So this is the current situation. These are German wind turbines, and here in this image there are 4 new wind turbines in the Netherlands. And this is on another location with, you see 6 current turbines, these, and here 4 more. And in the background, there are 4 Dutch turbines which are going to be realized. And here's another wind park. This is the current situation without wind turbines. And here are 7 wind turbines, which are, it's a planning phase. So municipality use these images to inform the citizens. I'm going to show you something in our program in Wind3D. And this is our 3D environment. We can use some GIS information. So this is our study area near the city of Harfsen. It's close to our office. It's close to the city of Deventer. And I can add some GIS information to it, like, for example, the main roads or nature areas. I'll zoom in to the office. I've put some things ready yet. We can do something with vegetation, because these trees are modeled already, but on the aerial photo I see that there are more trees, and the same here along the road and this little forest here. So I added can add some new vegetation to it. And what we can also do is a solar park. It's easy to in this program to see different scenarios. This is a south-oriented solar park, but we can also get an east-west oriented solar park. And we can look at it from the road. So we can stand here on the road. I see I made it more pavement than a road in this. So this is the view from the south-oriented solar park, and here the east-west. What I can also do is some landscape integration. I put some shrubs here at the corner, so we cannot see the solar park from the office. This is the ROM3D office. And if I stand at the road, I don't want to, first of all, I don't want to see the solar park. So I put some vegetation there. I can also remove it. And the same we can do for wind energy. So I made a line setup of 4 large wind turbines, 200 meters high. But I can also switch to a grid or a line with smaller wind turbines, and also the grid with the smaller turbines. And when we look at it from the office, this is the smaller grid, well, small. These are 155 meters high. I also have, for example, this view. These are 200 meters high. So we can use a lot of information we can put in to make visualizations. And the same, I can put these anywhere I want. So, for example, if we have a residence meeting and a resident says, well, I want a wind turbine next to this house here, then I can open a drag and drop menu, and I can look for a wind turbine. For example, this Vestas V112 turbine with a hub height of 190 meters, and I can put it on the ground anywhere I want. And I can also remove them if I don't like the place where I put it. I'll put it on another location. And the red areas are zones around the wind turbines that needs to be free of other wind turbines. So these red ovals, they may not overlap. So you can also turn them off and locate the wind park of the wind turbine somewhere else. I can look at it from some random house. I can look at the wind turbine, how it will look from here. So we can stand basically in everyone's backyard and visualize the impact of the wind turbine. Let's see if there are already questions in between before I go to the next part.
Yeah, there's actually one question. How are the reactions of the target groups, municipalities, civilians on these visualization technologies so far? And does visualizing make decision-making on realizing wind and solar parks easier?
The first questions, the reactions, most of the time everyone is really happy with the visualizations because it makes a lot clear on what you're talking about. We can talk about 200-meter high wind turbine, but yeah, what's 200 meters? And if you visualize it from really close, it's much more impact than when you're like 3-4 kilometers away. So everyone is quite happy with the visualizations in informing. They might not be happy with the result that they see, because well, a solar park is very close to their house, for example. And I'm not sure if it makes the decision making easier, because there's more than just the visualization. It's a lot of emotion going on with it, but it can make the conversation clearer and have an honest conversation about what you see. So that it does help with decision making, but I'm not sure whether it's really making it easier. It can also make it more difficult if you have only a map with locations. It's harder to imagine the spatial impact, and if it says, okay, this is 200 meters high or 150 meters high, well, you can imagine that from a 2D map, you cannot imagine the spatial impact. But when you stand in front of it within the 3D environment, yes, in that case, it does make it maybe more difficult to really get the plans for the higher variant. And what we hear is that people feel that they are more involved because they can point locations, or they can look from certain locations. If you have only photo visualizations, you're fixed to that position, and within this 3D environment, you can go to any location that you want. Well, then I suggest to continue with simulating resonance participation. For that, we use Miro. Miro is an online whiteboard. I have it set up here. And I would like Arjan to pick a location on the map. And with this location, I'm going to put a wind turbine at the location that Arjan chooses. Yeah, so you can see Arjan here.
My house is right over here, so I would like to see the wind turbine from my back garden. And I have another property. Well, it's not true, of course, but I'm just pretending. I have a little farm over here, so I'm interested in the view from the farm as well. And I think they were planning to build a turbine right over there.
Okay, thank you, Arjan. Well, Arjan is now the resident. He pointed out his house and his other property and the wind turbine. So I'm going to visualize that in our 3D program to see the impact of it. So we have Harfsen here. I'm going to zoom to the location that Arjan pointed out, which is in this field. I'm going to find a wind turbine. Let's take the one we had as an example. And
what's the height of this one?
One thing. Sorry, Arjan, what did you say?
What is the height of this turbine?
And this one is 119 meters hub height, so probably around 220 meters total height. You can
that's significant, yeah.
Check it here. I have this ruler. This one is 180 meters high. Yeah. More or less 175. Yeah. And then we have have the location where we should go. It is, let's see, this farm. Let's stand here. Well, there's quite some impact from this location. I'll save the locations. In here, get automatically the address. And in the background, we see the other turbines as well that that I put there. I can turn them off for the purpose of this visualization.
And can you measure the distance to the turbine?
Yes. From here, it's 280 meters.
Okay.
So this turbine will never be located here because it's just too close on the building. But for the purpose of this demonstration, it may be nice. And then we fly to the city of Harsen.
Yeah, over there. Yeah.
And we see that the wind turbine is not visible from here because there's some trees in front of it. But there it is. So from here, we can basically go to every location from where we want to view it. And for instance, stand here somewhere in the field. Well, depending on your location, you can see it, or you can't see it because of the trees.
There are two questions. I'll read them for you. Can you correct for the prevailing wind direction or different wind directions?
Yes, that is possible. I can show you. We have this. There's a navigation. And I can change the wind direction and the wind speed. A little bit too high, turbines needs to be stopped. And what we can also do with this is change the date and time. So in the evening, you see the shadow of the turbine changing. So we can also visualize the impact of the shadow flicker.
And that was the second question indeed.
And we can basically find any day and time.
Can we actually do shadow calculations in Wind3D, like exporting how many hours the shadow will be at a certain location?
Oh, that's a good question. I'm not sure whether that's possible. I never did it myself. But if we really want to do calculations like that, we can, well, we have our own developer, so we can develop quite a lot based on the question. I can show you something about, for example, an analysis that you can do with it. For example, to see where it is possible to place a wind turbine based on, it's called the Handboek Risicozonering. It's a manual with prescribed zones. For example, based on the main roads, you can't locate wind turbine too close to the main road. There's some pipelines, underground pipelines, which you should take into account. Nature should be taken into account, so we can put all these layers, we can turn them on. We don't not want it in urban area. You can put a layer over there. And of course, you should take some zones around the houses into account. So created a layer with all rural houses and urban houses. And these are locations that are everywhere where there's no layer, you can put a wind turbine. Modified the distances a little bit because these distances are too small. Because I did want some room, some places where the turbines could be located. It's now 250 meters, but yeah, it's soon you need 300 to 400 meters due to noise from wind turbines.
There's a question as well. Can those layers be imported from the Warmteatlas or other data sources?
Yes, we can have both shapefiles, we can upload them. But if the Warmteatlas has a WMS connection, we can add that as well, or a WFS service. So this is a basis BRP is the basic registrations of percelen of the grass, the lands. And we also have the national road bestand files of the Netherlands, which can also yeah, my colleague already put them in here. So I can put them, I can read them in as well.
And another obvious question is what needs to be done to use it in Germany?
To do this in Germany, we need some basic information, which is a digital elevation model. I'll go back to the presentation because I have a slide from it. It's a digital elevation model that we need. We need the building data, water bodies, vegetation, and aerial photo. Well, vegetation is not really a must-have. We can also draw that in, but then it's really useful if we have aerial photo. And depending on the size of the study area, yeah, you do not want to do everything manual. And water bodies actually the same, and the building data. Well, if there is building data available, it's good to import that, and otherwise we can also use the drag and drop option that I also used for the vegetation, for the wind turbines.
And what role has this program been used if in online discussions over wind projects? How do you use it? I mean, it's, well, yeah. Can you tell something about how the meeting is organized and what role the program has?
Yeah, I can tell you something about it. It was last year when we already also had to do with the COVID circumstances, and it's for this a solar park or energy landscape actually near Welsmeer. It's the 4 wind turbines that I already showed with the augmented reality. At the location of those wind turbines, there is also a solar park planned of 400 hectares. So it's quite a large energy landscape. And the municipality, they invited the residents of the and the people who live close to the park. And there we had this model, and we could answer questions, for example, based on the shadow flicker. If they have they can have some problems with it. They can see what it will look like from their viewpoint, and in that there it helped the people a lot to get more grip on what it meant that the wind turbines were placed there, and yeah, with the shadow drop, they could see that they did not have any problems with it because it would just go past their house or not get close to it. And it's more to really see it. It makes a lot clear, more than reading it from a document.
Yeah. So the municipality organizes an evening just to make the people understand what's going to happen. It was not meant to adapt to the plans or anything, or to make objections, but to understand the plans.
Yeah, in this case, it was really to understand it. But we have also used it in design sessions. Not myself, but colleagues used it in design sessions when it was before the COVID, and there were like 5 to 10 people sitting around the table having a design session, and they were finding locations which might be suitable or might not be suitable for example, for wind energy. And then one of my colleagues sat there with this 3D program, and while the people were trying to find locations, he was drawing in this 3D to see the spatial impact of a wind turbine. And based on that, the people, they adapted their decisions.
Okay, there is one new question. Is all this very nice information commercial or for free? I think Bavaria has something comparable, maybe not really. In the Energy Atlas, we don't have it in NRW, North Rhine-Westphalia. So far, it looks very helpful for fair planning and information for local people. So the question, the first question is it commercial or for free?
The information that we use is all for free, but the program itself is commercial. So if we are asked to make visualizations of a wind turbine, we use free information, but yeah, it takes quite some workload to visualize it. So that's commercial. But we also have some licenses so people can make the visualizations themselves. And we give them the program and the information. These are all tiles which you can load. And we give them the tiles with the information, and they can make their own visualizations.
Maybe I can add to that, since ROM3D is also a project partner of Task Force. I've talked to Ian before, and we'd be more than happy to at least start using that software with you within the project of Task Force, and we would need to discuss how far we can go with that support. But I think Ian, you said you'd be happy to at least demonstrate to municipalities, for example, what the benefits of this software are, and how municipalities can use it, and maybe just give a few demonstrations within their area.
Yeah, that's right what you were saying. I should add that this is basically focused on heat net planning. So the wind energy and solar energy for electricity, that's basically a more or less finished product, but we're still developing and looking for what role this program can play in the part of heat planning. Sometimes it's very similar to solar planning if you want to plan a solar thermal site. So if communities are interested in that, just approach VFM and we can see how we can cooperate in making visualizations for heat networks. Yeah. There is one more question. Do you have examples of visualization based in an urban environment?
I think I can best show this viewer. This is more in an urban area. And of course, I can also, within the 3D program, I can walk through a city.
Right now, there is very little information on on pavements and gardens and street furniture and stuff. I thought I heard that we were working on that as well.
Yes, that's true. We can, from the road files, we can automatically draw all roads, but I can also do that manually. And I have an example of that in near their office. So this is the pavement that I drew.
Yeah.
I planned to make a road, but I didn't. I didn't look at correctly. But and I can also turn this off. This is the original, and I drew a road over it to make it more realistic. But I can also select other road types. That's the same in we did that as well in the movies that I showed previously in the presentation.
And there's also a difference if things have to be interactive, then there is less detail in the near field, so to say. If we really want to make a visualization, then we have to add detail, basically manually for the perfect picture.
I'll put the link to the Miro board in the chat because I have some impressions there as well with the movie of the business park, the AR visualization that I just showed in the presentation, another movie about energy transition, and an example from a solar park. And the 3D viewers are also in here. The Salonse Heuvelrug, it's the first one with the nature restoration. And the second one is the Carolina Polder. It's this viewer.
There are several people there already.
Yeah, you can see them. You can see them pop in. And if you have any more questions, here are my my email addresses here as well, so you can contact me if you have if you think of some questions after this webinar. And in the movies, you can see also my colleague has put some nice road in here, which is more realistic than the aerial photo. And the same with the movie of the shadow flicker, where we have some cars driving over the road as well, and also put some paid some more attention to the detail level of the road and the traffic signs.
Right. So Ian, if I got you right, there will be another webinar in the next weeks. Maybe you can just tease what exactly it is you will be talking about there.
I will use Win3D a little bit, but I'll talk about basically about heat strategies and the effects that heat strategies will have on the landscape. So, like how much biomass would you need to be, would you need to grow around a certain village if this village want to be self-sustainable? How many biogas installations would you need? How many wind turbines would you need? And it's all in relation to the choices that you make in the heat transition. Like, do you want to use an all electric strategy in your village, like all individual heat pumps? In that case, you would need a lot of backup power and a lot of wind turbines to provide the electricity in the winter. On the other hand, if you wanted to have a buffer, a heat buffer, then maybe you would need a lot less transmission lines. What's the? I think I should call it transmission lines. I mean, transmission lines are not that intrusive in the landscape usually, but still, it can be very costly to. Well, if your network has to be 10 times as heavy as in another alternative, so that's basically the discussion I will be doing. Like, what options do you have, and what's going to happen with the landscape that we live in?
All right, thank you. I think this workshop you just teased will be taking place on May 19th.
Yeah.
Thanks to the both of you, especially Dillen, for preparing this presentation and giving this short demonstration about what Win3D can do and 3D modeling in general can do, especially in terms of communication. Yeah, the scheduled hour of this webinar is over now. I'll just say thank you to all of you for participating and attending this webinar. And I'd be more than happy to see you again on May 19th at 3 o'clock, I think it is again. Have a nice day and see you then. Thank you all.
Bye-bye.